Hello everyone, and welcome to this latest webinar from IHS Markit titled Building Flexible Networks with Open Optical Line Systems and SDN. SDN and Open OLS have the potential to give service providers and other optical network operators unprecedented flexibility in how they choose and deploy vendors. Today, our panel will examine the benefits and challenges associated with Open OLS and provide an update on recent advances in standards, hardware, and operational systems. Our webinar is co-presented by IHS Markit and our partners Fujitsu and Lumentum. My name is Alan Tatara, Event Manager for the IHS Markit Technology Webinar team, and I want to thank everyone for joining us. So before we get started, I just want to highlight a few features that are available for you and also how you can make the most of your experience with us today. So the webinar console that you're looking at is completely customizable, and you can open, close, move, or resize any of the windows that you have open on your screen and arrange the console as you wish. Now, at the bottom of your audience console, you'll notice a number of application widgets which contain additional features available for you. So please check these out during the webinar. But one button I do want to call out is the Resource List widget. And this is the green button that has a document icon on it. And this is where you're going to find additional material about today's topic, including the downloadable slide deck from our session today, as well as other valuable resources, including a special report from Senior Research Director Heidi Adams. And all these can be accessed and downloaded right from your console. And we do want to make this an interactive session, so we've included a Twitter widget at the bottom of your screen, so you will be able to tweet directly from the console. And today we are using the hashtag Optical Networks. We will also have a live Q&A session directly after the presentation, so please submit your questions or comments at any time by using that Q&A box on the left side of your screen. And we will try to get to as many questions as possible, so please enter these early and often. So now let me introduce our panel. First, leading our discussion is Heidi Adams. Heidi is Senior Research Director in the Transport Networks segment at IHS Markit. Also joining us is Joseph Masarino, Principal Solutions Architect in the Optical Networking Group at Fujitsu Network Communications. And rounding out our panel, we have Rajkumar Nagarajan, Senior Product Line Manager at Lumentum. So welcome to all of our speakers today. So now let's get started with our presentation. So Heidi, I'll turn it over to you.
Awesome. Thanks, Alan, and thanks everyone for joining us on our webinar today, Building Flexible Networks with Open Optical Line Systems and SDN. As Alan mentioned, today joining us on our call, we have speakers from both Lumentum and Fujitsu who have been working on developing on this opportunity to develop open optical line systems equipment. And in the case of Fujitsu, also working on the software side and SDN side of the equation as well. So looking at our agenda for today, we'll dig into a little bit of where we're at in the market today. We'll look at what we're hearing from network operators with respect to some of the opportunities they see ahead as we look to introduce more openness into our optical networks. We'll also have a look at some of the new solutions under development, and we'll hear some examples and look at reference architectures that are being explored within the context of open optical networking. And then also we'll move over to an audience Q&A. So as mentioned earlier, we'll do a live Q&A at the end of the session. If you have any questions as we go along, please do enter them into the console. So with that, let's get started. Where are we today? Without a doubt, I'd say lots of animated discussion in the industry right now about the opportunity and the challenges associated with this move towards more open solutions within optical networks. So in this piece of the presentation, I'd like to touch on some of the working groups, some of the hardware and software-oriented initiatives that are active in this space today. Top of mind and top of chart, the Telecom Infra Project. If you haven't heard of them, you'll probably be hearing a little bit more from this group. And in particular, there's the Open Optical Packet Transport Project within TIP. And this is made up of a group of service providers. It includes Deutsche Telekom, Telefonica, Vodafone, and others, joined up with a range of equipment vendors and optical component vendors as well, all tasked with the mandate of trying to enable a more open WDM transport infrastructure, and this including both optical line systems and the control side as well. Just a couple of weeks ago, early November timeframe, as part of a meeting that they had in California at that time, Facebook announced their contribution to this working group in the form of something called the Voyager platform. This was quite an interesting announcement. It's a 1RU white box transponder with a bit of routing added in type solution. We heard from a few of the vendors also in this time frame earlier this month that had done some field trial work in this area, and we're going to hear a little bit more about this today as we go on into the presentation. The second area that's quite active in this domain, the Open ROADM group, the Open ROADM MSA, initially led by AT&T, seeking to provide an environment for open optical line systems and looking to provide some standardized specifications for ROADMs and the line systems that connect into them. So we'll also hear a little bit more about this initiative today as well. Now, putting the hardware and equipment piece aside, there's also a wide variety of groups that play on the software side, and especially on the API side as well. Of late, the Optical Internetworking Forum, the OIF, has recently kicked off an SDN controller interoperability event where they're looking at, in particular, testing something they've introduced, the TAPI interface. This is look to be a more standardized approach for providing communications between the optical equipment, its controllers, controllers of controllers, and even the applications. And this group is leveraging some of the work out of the ONF, and we should hear some of the results from those activities later on in the year and into early 2017. And then if you look at the SDN controller, so moving to the bottom center of this chart, of course, many efforts today to build open-based solutions or on a base of open software that can be leveraged. And of course, ONOS and Open Daylight are two of the key groups in this space as well. So if you look across the industry, there is absolutely no lack of activity. There's no lack of effort. If anything, maybe you could argue there's too many activities in some areas and perhaps some competing interests. But at the bottom of it all, if you look at it from an optical networking perspective, the real question is, where is this all going to go? How real is this going to be? Are the objectives and the goals of the organizations and the vendors and operators behind the organizations, are they realistic? Are they achievable? Lots of questions. Are we going to be willing to trade off performance for interoperability? Who's going to do all the integration work? What are the new business models? So let's have a look at a few of these questions. This is the goal for what we'll be tackling today. So to kick us off, I'd just like to bring in a little bit of the research we've done here at IHS Markit and maybe put a little more context around some of the discussion. So first off, it is still very early days for open optical line systems. From a recent survey that we conducted, we probed for network operator appetite to take on open optical line systems, and we define this as separation of hardware components used in the transmission network and the software components, enabling them to purchased from different vendors or customized. And of course, within the open line system, it's a separation from line equipment from, say, the client side and transponders. So results from that, about a third are considering the use of optical line systems, and you've still got a huge chunk, 37%, that are undecided, and a further 13% that are not familiar. So early days and still an opportunity both for education and to see how things are going to proceed within the industry. From the same survey, we also had checked in on the current view of what would be the expected drivers of going down this path. what are we hoping to achieve in considering open line systems? And at the very, very top of the list came out a reduced reliance on single vendor solution. And then if you go down the list, you can see several things with respect to reducing costs. So less CapEx through better negotiating power, better performance in terms of being able to select best in class from the different aspects, components of the solution, and then this decoupling of hardware from fixed hardware releases, so being able to decouple software from hardware. If you put this all together, I think at the heart, one of the key enablers, or one of the key things that's going to need to happen to enable this is probably more interoperability within optical line systems moving forward.
Heidi, have we lost you?
Okay.
Well, I'll tell you what. There you are. Okay.
Okay, okay. So, all right. So SDN, key enabler for open. On the SDN side, we believe that SDN is a key requirement for the deployment of optical line systems, and that the pace of adoption for OLS is really going to be dependent on the rate of adoption of SDN within networks as well. So looking at the key deployment drivers for SDN, what are folks looking for as they introduce this into the network from a recent service provider study? Top one, simplification and automation of network provisioning and service provisioning, quicker introduction of new services, and end-to-end service management and network management. And if you look at these as key functions, those are also some of the key elements that are going to be required as we move towards open optical line systems. So strong role in the network, from a service provisioning perspective, and again, that enabling interoperability between different elements at different layers and between different vendors. So with that, I'm going to hand over and move into this next section, and let's have a look at some of the problems and challenges or opportunities that are being enabled by more open optical line systems.
Hey, thank you very much, Heidi. And I'll give you the Lumentum's perspective, looking at the universe from the bottom, looking up. And what we see typically is that in the current service provider OSS-based systems, long back-end integration and certification timelines, slow deployment of new network technology, architectures, and service. Service providers have often mentioned that it takes up to 18 months, sometimes even longer, to turn up new service with the current OSS-based models. Networks that are deployed today are very domain-specific, which means that usually when a network is built out region by region, the deployed equipment is from a single vendor under their NMS/EMS umbrella. Handoffs often from one vendor to the other is more often at layers 1, 2, 3. Lack of interop between the vendors at the optical or the layer 0 due to a mismatch at the control and the physical layer leads to underutilization of the capital in the service provider's inventory, as equipment cannot be redeployed from one domain to the other or from one geographic region to the other. Carriers, like all other companies, are under the pressure to increase their revenues while still being asked to operate within their CapEx envelopes. Now, new services will bring new revenue if the network were scalable instead of being fixed, cognitive instead of being static, automated instead of being manual. A move to a programmable network will enable better network utilization and allow new services offerings to be built at a faster pace. But the network would still need to offer the same mission-critical performance with a high availability. Now, this aspect is one big difference between, say, an internet content data network and a telco cloud mobility network. As a telco, looking forward, needs to support latency-sensitive IoT applications of the future, like cool stuff like automated cars, self-driving delivery trucks, and such. Now, I'd like to pass on the baton to Joseph to hear his perspectives.
Thank you, Raj. At Fujitsu, we have found service provider to have significant challenges in two key areas, one being organizational within the overall operations of their network, and the other in delivering service delivery, actually accelerating service delivery in a more dynamic fashion, reducing the time it takes to roll out a new service. Based on our research and experience, we found the greatest challenges within the existing service provider organization than that with the technology itself. And quite simply, the challenge is getting existing teams to change from their comfort zone to a new unfamiliar technology that has levels of automation that will essentially expedite the overall operation. There's also some new skills that are needed for this, and moving into those new skills requires a staff that can embrace that new skill set. On the service delivery side, we found that all service providers have a desire to efficiently activate a new service in days, hours, even minutes, ideally, instead of the usual many months or weeks. And this is a result of multi-layer, multi-vendor network elements from the core to the customer access point. And these somewhat disparate network elements lack the visibility of performance monitoring and end-to-end connectivity and control, a uniform ability to interoperate with one another, to provide seamless access with one another. And those are the areas that we have basically found to be challenges within the service provider area. Essentially, technology is easy. People are difficult in terms of moving from where they are today to the newer technologies, changing the organizational operation, and then embracing these new automated systems.
So with that, we're just going to take a quick moment and check in with the audience. Would love to hear from you, just a little bit based on what we've heard, but also from what you guys are experiencing. What do you consider to be the main barriers to deploying open optical line systems and or disaggregated optical systems? So have a look at this list, select all that apply. The first one is availability of hardware that supports this. Could be the availability of more mature SDN control management solutions in conjunction with OLS. Do you believe there's a requirement for solution integration? Who's going to do that? Is that a challenge? The availability and maturity of standards. So for interoperability, making sure all these pieces are going to hang together as we start to split apart different components. And finally, perhaps you're looking at after installation, and you can also indicate others. So have a look through this. Click on as many as apply. And I'll give you 3, 2, 1. And let's have a look at the results. Okay, so it looks like everything's a challenge. The key one that popped out with almost 65% of the audience, solution integration, emerging as that top challenge. Find that at over half the audience, the availability of mature SDN control management solutions and standards for interoperability. So I think with respect to what we've heard from our speakers and some of the pieces we're going to address in the session, this is bang on and in alignment with what we're hearing from the industry in general. So thank you for that. With that, let's move on to the next section. Let's have a look at some of the emerging options and solutions in this space. And to put that in context, I'm just going to step back for a quick second and just have a look at, again, this world of open optical line systems or open line systems and disaggregation. What's what? How does it all fit? Is it the same thing? Is it different? And from an IHS Markit perspective, when we look at this market, when I look at this market, I fundamentally divide things into hardware and software. And I look at I look at it as a spectrum. So from one end on full disaggregation, you could have a range of hardware components, be it the ROADM, the amplifier, the transponders, even the packet fabric if you're doing layer 2 switching and layer 2 Ethernet services. And then on the software side, there's a range. You've got your control plane, be it distributed or centralized. You've got alarm handling. You've got power management, restoration capabilities. You've got network topology and resource management. As you go up, of course, you've got the various applications that would enable bandwidth on demand or calendaring, and of course, service provisioning and assurance capabilities. So in a fully disaggregated system, in theory, you can pick and choose amongst all of these, integrate them together, and off you go. On the opposite end of the spectrum, and something that's very real in networks today, you could take a fully integrated system, which could take the form, for example, like in a packet optical transport platform. And a lot of that's being deployed in the networks today. And when I look at open line systems, I see that as being somewhere in the middle of that spectrum, where you may have a fully integrated line system, but now you've separated that from client side, where you would have your transponders and everything else provided by different vendors operating over an open line system. And even generally in those systems, open interfaces such that you can interface northbound to an SDN controller and to higher level applications that can then take advantage of the hardware. So there's a range of options, there's a range of definitions, but I think the approach really depends on the goals and the applications you're trying to deploy in the network. So with that, I'm going to hand back over, and I will start with Lumentum and then go on to Fujitsu, and we'll hear about some of the different applications and constructs being worked on today. So Raj? Raj, are you on mute? Come back to us, please.
Thanks, Heidi. The optical solutions in the market today are proprietary systems which are highly integrated across the hardware, software, and the application layers. If these layers can be separated or disaggregated, one can accelerate the pace of innovation by allowing new best-in-class hardware to be deployed in a multi-vendor software-controlled environment. This would allow newer applications and service models which take advantage of the latest technology to be developed by all players in the industry. Network operators would no longer have to be limited to a single vendor to provide all the items on their wish list and could blend a network with a best-in-class multi-vendor solution. Now, significant market activity is ongoing to explore the separation of hardware, network control software, and the application software. Multiple consortia are being formed, as Heidi mentioned earlier in her introduction, to align the framework for an open networking example, the TIP and the AT&T Open ROADM. Now, active participation from all layers of the optical networking value chain, which includes operators, system vendors, integrators, component vendors like us, and contract manufacturers will be critical for the success of this new paradigm. Now, let's take back and take a look at applicability of an open networking. Right? So what we have shown here on this slide here is a disaggregation model, and disaggregation at various levels. On the extreme left is an example, at the bottom left quadrant is an example of a least disaggregated system. This depicts a single vendor solution for a given regional domain of the network. This is how networks are deployed today. The interface with the SDN layer, in this case, will have to be at the NMS or the EMS layer. The picture in the middle shows partial disaggregation at the nodal level. In this case, a multi-vendor solution is built across a given regional domain, but at any node, it is a single vendor solution. The SDN controller can talk through any northbound interface like a netconf directly to the shelf controller, which in turn will have a proprietary interface to the various network elements. The AT&T Open ROADM initiative falls under this category of disaggregation. Then on the right is a fully disaggregated network down all the way to the network element level. The optical network is essentially an analog link. There are some link engineering trade-offs to be made with making a multi-vendor optical network deployment work. Different use cases have different tolerances to optical link layer fidelity. A long-haul network is designed by harvesting every last tenth of a dB, and one will actually continue to see the least amount of disaggregation in this sector. There will continue to be a tight coupling between the hardware, software, and the control plane in this area to maximize performance. The partial disaggregation model, shown in the middle, will first find adoption in the metro regional networks, where there is some level of latitude in terms of link engineering. There is, of course, a close coupling between the hardware and software layers, but less so at the control plane between the nodes in the region. Now, significant benefits can be had as network capital utilization can be maximized. The fully disaggregated model on the right is the fastest path for new innovations to make it into deployment. There are many use cases where the networking complexity is low, but new modulation techniques at lower price points need to be supported on a highly differentiated optical layer. And in this model, the SDN controller can talk directly to the individual network elements. Now, when one looks at disaggregation, say in the context of the solution, say that went into the intra-data center space where they use bare metal servers and switches, and there were benefits realized in deployment agility, faster innovation cycles, and supply chain diversity and value chain clarity. Now, if one were to look at what the benefits were there for that application space and what now to map the same advantages and look at which sector of the optical network would benefit most from disaggregation, I think we come to a common conclusion that it could be the metro edge and the DCI systems. And therefore, most of the optical white box activity in this industry targets the space. Over to you, Joe.
Thank you, Raj. At Fujitsu, we see many degrees of openness. As Raj has mentioned, there's degrees of openness in hardware. There's also degrees of openness in software. Open source software such as Hadoop and OpenStack and ONOS and Open Daylight, as well as open standards in the hardware, the Open ROADM, NSA project, TIP, and other open standards that are emerging through the industry. In hardware, the use of pluggable optics was an early use of openness made by a select group of component manufacturers and used on multiple optical line platforms from systems vendors. The next degree of openness in the hardware side is the evolution of the open line systems that you've heard from Heidi. And these open line systems are open-based ROADM and AMP elements, also disaggregated from the transponders within the systems, and also perhaps even switches within the systems. The open line systems, as in Open ROADM, will interoperate with any vendor's open-based transponder. And in this illustration, we see a progression from both hardware and software technology evolving towards this openness. And just as the hardware has seen a progression in openness, so do the software. So here we see the different progressions of openness as in different mixes of design within the networking layers. The first step in this level of openness is to develop a dynamic networking or provisioning with multi-vendor and multi-layer control across your access, transport, and switch layer. This is implementing an SDN control platform that will cut across all the three layers, again, the access, transport, and switch, to gain a complete view of the network with distributed control, the ability to route around faults, provide self-healing capabilities, most importantly, to provide an automation level, especially when provisioning services through these multi-layers end-to-end. This would expedite a overall service delivery in the shortest amount of time possible. We then move into a cross-functional operation on this particular display. And in the cross-functional operation with SDN control, we have the ability to mix vendor equipment across the transport functions. For instance, a transponder from one vendor will communicate with a ROADM from another vendor, but those transponders are essentially bookended from the same vendor but connected to a ROADM from another vendor, and this breaks away from the traditional converged system approach into a more disaggregated open approach going forward. The next step is this intra-functional operation with SDN control, the ability to mix vendors' equipment within a single function, such as, again, that transponder. You have a transponder at one end from vendor A, for example, communicating with the transponder at the remote end from a different vendor, vendor B in this case. And same with the ROADM itself, two different vendors interacting with one another on an end-to-end service, providing the same function, but again, from different vendors. This multi-vendor availability will support a reduced supply chain, reducing risk in the supply chain, and also reducing risk of product discontinuance from a particular vendor. If one were to drop out, not have inventory available when a service needs to be turned up, another vendor could easily be placed in to turn up that service quickly without having to wait for the particular vendor to provide their equipment. The other area which is most interesting is the split functional operation with SDN control. This is where you take a particular function and you split that function up, and the function is split between both the virtual and physical layer, where you take the actual core function, you break out a commodity part of that function that is then commoditized either via hardware, physical hardware itself, or virtually through a virtualization function going forward within the network. And this is a two-part slide that shows on this second part how that split function operation will virtualize both on the physical side and also on the software side going forward.
All right. Thank you, Joe. Thank you, Raj. So after that look at some of the new options and deployment approaches, let's move on to looking at some of the recently conducted use case and trial activities in this area. So with that, Raj, I'll get you to start us off.
Thanks, Heidi. So what we have here in this chart is a simple illustration of an open line system model. The picture below represents a linear point-to-point link where the photonic layer, like the amps, the mux, demuxes, etc., are provided by one or many vendors, and the interface specs. And the interface specs at the optical layer have to be clearly defined to be agnostic to the transponder vendors feeding into this line system. The northbound management interface could interact directly with the SDN controller or through a multi-protocol mediation layer in between. The transponder solutions that feed into this line system could be bookended solutions and multiple vendors, say, occupying different wavelength slots, kind of a subset of what Joe spoke in his previous slides. Now, a good example of a system such as this would be the Voyager Open Line System field trial, which was announced publicly on November 1st at the TIP Summit held at the Facebook headquarters. So in this trial, an open line system was deployed between two Equinix data center sites from San Jose to Palo Alto, which is about 50 kilometers of dark fiber. And the line systems were fed using the recently unveiled Voyager transponders to carry 200 gigabit per second signals on each wavelength. The Voyager transponder box is shown in the picture at the bottom. Was a collaborative effort between Facebook, Acacia, Broadcom, and Celestica. And the elements of the line system that went into making this trial, such as the amps, mux, demuxes, were built out of using Lumentum's white boxes. There was another partner company called Snaptrout that provided the software layer to communicate and mediate with all the different network elements. This particular setup carried 4 wavelengths, I think, for a link capacity of 800 gigabits between the 2 sites. And in order to explore this open line system concept further, the reach was extended to about 170 kilometers by adding about 120 kilometers of lumped fiber in the lab at one end. For those interested, I mean, the BER obtained for this link, for the various different distances in the link was shown on the top right-hand quadrant. I think the dotted line on that graph shows the point where the FEC falls over the cliff. Now, this is a relatively simple link, but it does serve as an example as to how a disaggregation model could work. With that, over to you, Joe.
Thanks, Raj. The Open ROADM multi-source agreement is a great example of degrees of openness I described earlier. And this is where the open-based multi-vendor hardware and software is blended to provide an end-to-end solution beyond an open line system. The traditional ROADM and transponder are disaggregated, and each component is SDN enabled. Through this level of openness, one vendor's transponder directly interconnects with a different vendor's ROADM, including the transponder with the open line system forms an open optical transport system end-to-end. And this end result offers the service provider freedom to procure equipment from multiple vendors, allowing more competitive pricing, faster scaling, reduced risk of manufacturer discontinuance versus a single vendor approach. Another example that I'm showing here is the ONOS eCord use case. And eCord stands for the Enterprise Central Office Re-architected as a Data Center. This was a proof of concept that was demonstrated live at OFC earlier this year. And the project is a collaborative effort between leading service providers, AT&T, China Unicom, NTT Communications, and several optical equipment vendors in the networking space, including Fujitsu and Lumentum, among others. The proof of concept consists of a packet optical metro network with 3 central offices as cord sites. Portals and GUIs are used to configure enterprise services, interact with operational parameters, and visualize the provisioning. Another example of the disaggregated ROADM was used in this POC, and the disaggregated ROADM moves away from a closed, chassis-based proprietary approach to an open model controlled using open interfaces and protocols.
All right, so before we move on to our next section, you've, in the audience, have just heard some of the use cases, some examples, and you've also heard a few thoughts on what applications or where this may or may not be relevant. So at this stage, we'd just like to take a moment and hear some of your thoughts. So a little survey question. What do you see as being the primary use case or initial applications where we may see the deployment of open optical line systems or optical disaggregation? Please select all that apply. Do you see this in long-haul applications? Maybe the longer metro-regional type applications, metro access, more specifically perhaps data center interconnect, maybe other applications, or maybe at this stage you haven't, don't really know. So take a couple of seconds, 3, 2, 1. And let's see. Well, it looks like our runaway lead application in this space is Data Center Interconnect. Not a surprise. Pretty close to 70% of those of you up on the audience. What's interesting is we do see some potential interest in long haul, but metro regional, metro access, which ties in probably with a lot of what we're seeing on the Data Center Interconnect side as well. So some very good feedback, some interesting insight from the audience. Thank you very much. All right, so just before we move on, just a reminder to the audience, if you have any questions for our panelists, please feel free to use the widget below and to enter in any questions you may have. And just before we wrap up, we'll have a little bit of time for Q&A with our panelists, plural. So with that, just like to give each of our sponsors, Fujitsu and Lumentum, a moment to share a little bit about some of the offerings they are bringing to market in this area. So Raj, to you first.
Thank you. Lumentum has always been a leading provider of optical components, modules, and line card solutions to the optical industry for the last several decades. And in keeping with our role as an innovative hardware provider, we have recently launched a portfolio of optical hardware white box solutions. A subset of our white box offerings is shown on this slide. On the left, the terminal amp will be used in conjunction with a mux demux to boost the signals from a transponder before it's launched into a fiber, and also to preamplify the received signal to compensate for fiber losses before detection. The terminal amp, when used in a bookended configuration, can also be used to provide a 1+1 line protection for diverse path. The line amplifier, the one that's shown in the middle, is intended to build a multi-span system whenever repair is required. And the ROADM white box on the extreme right has all the optical components inside it to provide the functions required for a nodal degree. It also serves as a platform to provide colorless mux-demux function and a good vehicle for superchannel aggregation. Using these white boxes, any system integrator or equipment vendor can build a line system by combining it with other hardware solutions. On the software side, easy integration is made possible with the northbound netconf YANG interface. The optical supervisory channel is a fairly standard 100 meg stroke GIGI Ethernet link, and that provides very easy interoperability with other systems. Lumentum believes that this platform allows us to quickly bring to market each successive generation of new optical technology advances within the photonic layer. Equipment vendors can leverage the platform and its capabilities to quickly offer targeted economical solutions without the burden of long custom development. The platform has been built with our years of experience in building the best-in-class optical gear. Much of the detailed specifications of the white boxes shown here have been made available to the TIP community and actually can be downloaded from the TIP website. Additional details and contact information can also be found on the Lumentum website. With that, over to you, Joe.
Thank you, Raj. Fujitsu has an open architecture consisting of open hardware, software, a proliferation of standard protocols, and our services team. This winning combination of modular hardware, software control systems, and the knowledge and insight to design, install, test, and provide the day-to-day management of an overall end-to-end optical solution is key to the benefits in using Fujitsu as your partner going forward. The hardware of our Onefinity modular open optical portfolio provides a modular hardware that goes beyond the open line system in that it has a series of transponders, white box switches, ROADM, and optical amps, all programmable via netconf YANG interconnect to a network controller. Our Ventura offers software control through its multi-layer, multi-vendor network controller, capable of integrating transport for layer 0 through 3 virtualization, and how the hardware and software can be combined to deliver innovative cloud services. The result in an SDN that is more modular, programmable, and adaptable. The key benefits of this solution include a centralized control, which separates the control plane from the data plane in the network elements, flexibility enabling faster time to market and network setup, a vendor-neutral approach in terms of multi-vendor, multi-layer, open-source operation, and modularity, which disaggregates the hardware and software, offering flexible, best-of-breed, pay-as-you-grow scaling. Finally, the Fujitsu services offer that glue that pull it all together to provide that end-to-end solution. If you're a service provider that wants to move forward in an SDN environment, perhaps lacks the skill sets within the organizational environment, our services team can provide that design, install, integration, and ongoing management with the complete multi-vendor services for a full life cycle of your network, including consulting, design, and build to operate and maintain services. Heidi?
All right, so I'm starting to see some questions coming in, so please do continue to ask your questions. I'll just do a quick wrap up on the session. So our hope for key takeaways for the audience. First off, we heard a little bit about the potential for open optical line systems to eliminate vendor lock-in, enable best-of-breed, supply chain optimization in terms of some of the key drivers from our research. We also saw SDN combined with OLS driving some potential to enhance network service delivery and bring more flexibility, agility, automation to the network. So that was some of the initial research. We also heard from our survey that some of the key challenges include who's going to do the integration. We're going to require availability of an SDN layer for this. And we also heard, moving on in terms of some of the key findings, we heard from both Joe and from Raj a little bit about some of the market activity, some of the trials, some of the activities underway to do proofs of concept and demonstrate some of this technology in the network. And we heard from the audience today, data center interconnect and metro applications, most likely to be the lead areas where we'd consider the introduction of this technology into the network. And then finally, I think a key thought or a key takeaway, maybe from some of the words we heard from Joe today, this is going to be a significant transformation moving forward. There is a change of mindset required. There's going to require open and active participation from players from across the industry and also within the operators themselves. It becomes a real change of operational model. So definitely a significant transition ahead. So with that, wrapping up the presentation section of our session today, and I'd like to move over into the question and Q&A section. Lots of questions coming in, so let's see if we can pick a question, get us started off here. I've got one for Raj. It's on the looking at this white box model and the multi-vendor white box model. If you look at that type of approach, who would actually be responsible for addressing support or network support in those types of operating environments?
Thanks, Heidi. So typically, when we belong to the ecosystem where we supply the hardware, so typically there would often be a layer above us that does the system integration, and more often than not, they would be the first line of support who would be required to troubleshoot the link for the customer.
Okay, and I've got another quick question for you. The SFP ports that were shown on your white boxes, what are those used for?
Oh, okay. Those are the ones that are used for providing the optical supervisory channel if required. So you could plug in an SFP port, a transceiver on there, and then put a patch panel and loop it back into the box. Either there are two ports available there, one to operate in OSC at 1511 and the other one at 1610. So depending on your choice of this OSC that you want, you would loop it back into the box, and then you could then detect it at the far end of on the box that is subtended from the primary one.
Gotcha. Okay, a question for Joe. So as we move towards more open standards and we have more standardized platforms within the network, so a question to you as a vendor, how are you guys going to provide differentiation with your solutions moving forward?
That's a great question. Well, it takes a number of skills to differentiate in this new open equipment world that we're heading into. A vendor that understands the industry, it has the technology vision that leverages that institutional knowledge, a vendor that's engaged in and active in relevant open forums and projects, embraces agile development going forward, delivering those customer requirements in an accelerated fashion, supporting moving to open technologies at your own pace, and offering a range of services that support customer implementation. And maintaining those open standards will limit performance and innovation. So we've taken a bifurcated approach moving forward with our Onefinity portfolio. So in an open environment, everyone basically provides the same type of functionality going forward, and as new functionality is developed on a particular function or new capabilities developed on a particular function, that is then opened up to the world and other vendors can develop the same. So it makes somewhat of a similar or vanilla type of environment. There's pros and cons to that. The pros that we've mentioned throughout the webinar, reducing risk to the service provider and providing a more agile development going forward. But then there's also some cons associated with that, in that it stunts a level of innovation going forward. And so what we've taken is that bifurcated approach where we address all the open standards, but we have basically options on board our Onefinity portfolio to allow for more advanced features. So we have an open white box mode of operation, which conforms to the open standards. And then if you want extended performance, enhanced performance, you can then switch over to a proprietary mode that will provide that extended performance and innovation that we've provided for many, many years within Fujitsu in our optical portfolio of products.
Cool. I've got another question for you, Joe. But actually, there was an interesting comment that came into the Q&A. Great comment and a great reminder that, from an open line system perspective, this isn't something totally new. Like if you look at the subsea space in particular, and if you look at the upgrades going on to the cables or the systems there, we are seeing different vendor equipment, different vendor client systems, transponders being run over the existing wet plant and subsea systems. So, we have a use case example there, which is quite interesting. So this is quite real today from that perspective. So actually, with that in mind, so Joe, I'll get you to answer this question. Could you articulate, when you look at an open line system, what are the key elements in optical transport that would be included in the open line system?
So the open line, optical open line system is essentially the ROADM element consisting of the WSS and various optical amps that work with the ROADM. The Fujitsu Onefinity portfolio goes beyond that standard open line system, in that in addition to the ROADM and its variations, optical amps, etc., the Onefinity can also provide an open transponder, a layer 0 to 3 switch. Onefinity is essentially a modular open optical portfolio for building SDN solutions.
Cool. Thank you. Raj, I've got a question for you. So with respect to timing, when realistically do you think we're going to start seeing open line systems or aspects of disaggregated systems being introduced into the network? Is it later this year? Is it later on? What are you seeing from a Lumentum perspective?
Yeah, I think I'll just add some more color to it. I think there was a good, interesting comment made early on, which you just mentioned that, hey, open line systems have been there for a while. This is not completely new, and that is true. It has been there for subsea systems and also even for the terrestrial networks, because ever since the concept of supporting an alien wavelength came in, one cannot actually say that's the beginning of an open line system. Now, to address the particular question as to when will, say, white box type solutions be part of a solution space to build out an open line system, I would say sometime starting the middle of next year to end late next year would be the right time frame where you can actually see them deployed in the fields.
Okay, and open question to either of you. Who do you believe are going to be sort of the next wave of early adopters for this technology more into terrestrial systems? I guess probably in particular if you're looking into the Metro or DCI.
Okay,
Joe?
I'll give my take on it.
Or Raj? Yeah, go for it.
Sure. Okay. We are seeing interest across different spaces. We are primarily, the interface to us has been through system integrators who've actually put together not only the layer 0, but all the way up to the layer 2, 3, and so on, and this becomes part of that solution. And the solution space is mixed. We have seen, application spaces on the DCI side, and at the same time, some in niche applications in the service provider space as well.
Joe, do you have anything to add to that?
Right, I was going to say, we're seeing in both areas, both in that DCI area, of course, as a fast-moving, high-growth area, but also in the cord application, the CO re-architected as a data center, traditional telcos, MSO type service providers moving towards this data center approach using disaggregated components to build their optical network, providing savings in power and footprint, and providing a very fast scaling and programmable network moving forward.
All right, great. Okay, with that, I think we'll bring the Q&A session to a close. I'd like to hand back over to Alan for a little bit of a final wrap-up. Alan?
Thank you, Heidi, and I want to thank everyone for your participation on our webinar today and for submitting your questions and comments. A special thank you to Heidi for leading our discussion, as well as our presenters, Joe and Raj, for this very informative discussion as well. So an archived version of this webinar will be available shortly, and we'll be sending you a follow-up email on how to access that archive, or you can simply use that same audience link that was sent to you earlier. So feel free to come back and view this session again, or even share it with your colleagues. Now you're going to see a short survey pop up at the conclusion of our webinar. We'd love to get your feedback, so please take a few minutes to fill that out. And make sure you follow us on Twitter for information on future IHS Markit Technology webinars. So again, thank you for joining us, and have a great rest of your day.